Hi everyone, let's start paper 4 of A2, October-November 2024, variance 42. Let's start the paper. Question number 1, the equation for reaction 1 is shown. So reaction 1 in which X is basically your reactant converted into 2 moles of product, and product is basically your Y. Okay. Reaction 1 is first order with respect to the concentration of X. So if with respect to X, it is first order reaction, then it means its rate equation can be written in this way. Okay. The half-life of the reaction is 900 seconds at 20 degrees Celsius. All right. That's very straightforward. That half-life of the first order reaction is already given, which is 900 seconds at 20 degrees Celsius. A solution of X with a concentration of 0.18 mole per dm cube. So concentration of X is given 0.18 mole per dm cube, which is prepared at 20 degrees Celsius. Calculate the average rate of reaction 1 over the first 1800 seconds. Okay. So to calculate average rate, the formula is going to be change in concentration over time taken. In order to calculate the change in concentration, so the initial concentration is basically 0.180 mole per dm cube, and mole per dm cube is also called molar. So that concentration exists at 800 seconds. Okay. So that is the initial concentration technically. So in the first half-life, concentration is going to be half. 0.180 divided by 2, you will get 0.09. This is the first half-life. And obviously, I think it's basically 1800 seconds. Now, if I'll halve this concentration again, and exactly it has to be at 900 seconds. Divided by 2, you will get 0.05 mole per dm. Okay. So this is the first half-life. And this is the second half-life. So over the course of 1800 seconds, the concentration has to be 0.05 mole per dm cube. So initial concentration is 0.180. After the successive half-life, the concentration is going to be 0.05 mole per dm cube. So change in concentration 0.180 minus answer is going to be 0.135 mole per dm cube. Okay. So in order to calculate the average rate, I'm going to use this concentration and divide by this time. So I'll get the average rate. Let me plug in the values in this formula. 0.135 divided by 1800. So average rate is going to be 7.5 into 10 to the power minus 5 mole per dm cube second inverse. So हम यहाँ लिख सकते हैं 7.5 into 10 to the power minus 5 unit is going to be mole per dm cube second inverse. Okay. Complete the rate equation for reaction 1. So that's rate equals to K concentration of X. Show that the rate constant K is this at 20 degrees Celsius. So let me write the rate equation first. Rate equals to K concentration of X. So rate की value हम already calculate कर चुके हैं, which is 7.5 into 10 to the power minus 5 equals to K. Concentration of X is basically how much? 0.18 divided by 0.180. So it's going to be 4.166 into 10 to the power minus 4. And the unit is going to be second inverse. Okay. So let me check the calculation again. Let me check the calculation again. Oh, my bad, my bad. That's a very, very serious sort of mistake I'm done with. Actually, examiner is looking for the rate constant at 20 degrees Celsius, and at 20 degrees Celsius, the half-life was 900 seconds, right? And oh my goodness, so examiner, so ये value हमारी नहीं आई जो हमने pattern adopt किया, right? So since it is a first order reaction, so I'm gonna use T half equals to 0.693 over K. I need to find out the value of K, so I'll use 0.693 divided by T half. T half is 900, so K is going to be, let me check from this 0.693 divided by 900, because at 20 degrees Celsius, the half-life is just 7.70 into 10 to the power minus 4 second inverse. So that's the value we are looking for. Okay, so that's the right answer. So you guys have to be very, very careful. You need to read the question very carefully. Calculate the initial rate of reaction 1 when the concentration of X is this. Now I'm going to use that format जो कि मैंने थोड़ी देर पहले use किया. The rate equals to K concentration of X. I need to find out the value of rate. The value of K is already calculated in the previous part, which is 7.7 into 10 to the power minus 4. Concentration of X is going to be 1.50. So rate into 0.150. So rate is going to be 1.155 into 10 to the power minus 4. All right. So 1.16 into 10 to the power minus 4 mole per dm cube second inverse. That's the unit of rate. Catalyst may be homogeneous or heterogeneous. Platinum is a transition element. Explain why transition elements behaves as a catalyst. First of all, transition elements have vacant orbitals with close energy gap. So transition elements shows variable oxidation state due to the close energy gap between 4s and 3d orbital, and also electrons available in both 4s and 3d. Name the metal catalyst in the Heber's process. Iron is basically the catalyst used in Heber's process. Why it is heterogeneous catalyst? Because catalysts and reactants exist in different physical state. Okay. So next, platinum acts as a heterogeneous catalyst in the removal of nitrogen dioxide from the exhaust gases of car engine. Describe the mode of action of platinum catalyst in this process. So first of all, platinum is basically the heterogeneous catalyst, and in heterogeneous catalyst, adsorption and desorption takes place simultaneously. So first of all, let me tell you about the adsorption process. Platinum has active sites. So reacting molecules are adsorbed onto the surface of catalyst due to which internal bonds becomes weakened and due to series of steps products are formed which will leave the surface of catalyst through desorption. Okay. NO2 acts as a homogeneous catalyst because catalyst and reactants exist in same physical state. In the oxidation of atmospheric sulfur dioxide, write equations for the two reactions that occur. Nitrogen dioxide is basically an oxidizing agent. It is a gas at RTP. It oxidizes sulfur dioxide gas into sulfur trioxide in the atmosphere and reduces itself. Now, nitrogen monoxide in the atmosphere again oxidized with the atmospheric oxygen and converting it to nitrogen dioxide. So reaction start हुआ, gaseous nitrogen dioxide से वापस मिला gaseous nitrogen dioxide, acts as a homogeneous catalyst. All right, and that's what we have done in the class also. Sulfur dioxide dissolves in water forming H2SO3, and the equation for this reaction is going to be like this, which we have done in chemical periodicity in A1. So H2SO3 is basically sulfurous acid. Sulfurous acid can be oxidized under acidic condition. The equation for the half cell equation for sulfurous acid is given with an SCP value, which is plus 0.17 volt. 4 more half equations for the reactions occurring under acidic condition and their E0 values as shown. Select oxidizing agent that could oxidize sulfurous acid to sulfate ions under acidic condition. So if I need an oxidizing agent which can oxidize H2SO3 into sulfate ions, which means value needs to be greater than this value. So if this value is plus 0.17 volt, so the oxidizing agent which we need to select has a potential value greater than plus 0.17 volt. So look at the value which is greater than plus 0.7 volt, 17 volt is going to be this one. So BiO plus is basically an oxidizing agent which can oxidize sulfurous acid into sulfate ions. So oxidizing agent is BiO plus. So what we can do is, since this half cell has a more positive SCP value, so I will write the equation in the reduction form as it is. And since this half cell has a less positive SCP value, so I need to flip this equation. So if I'll flip this equation is going to be like this. H2SO3 plus water, sulfate ions, plus 4 hydrogen ions, and plus 2 electrons. So in order to write the overall equation, we need to balance the number of electrons. And for that, I will multiply this equation by 2 and this equation by 3 so that number of electrons are balanced. As soon as the number of electrons are balanced, they will cancel out with each other. Obviously, this 6 hydrogen ions cancel out with 8 hydrogen ions. This 3 water molecule cancel out with 2 water molecule. So the final equation can be written like in this way: 2 BiO plus 3 H2SO3. So we have 3 moles of water here and 2 moles of water here. So when cancel out with each other, only 1 water molecule left. Arrow 3 sulfate ions plus 2 bismuth. So this is 3 times 4, 8 hydrogen ions. This is 2 times 2, 4 hydrogen ions. When you cancel out each other, so 3 times 4 is 12 to the 4, 8 hydrogen ions left. So that's the balanced chemical equation. For the overall reaction, we need to find out the E0 cell value. So I'm going to apply E0 right minus E0 left formula. In E0 right, we need to put more positive SCP value, which is plus 0.28 volt. In E0 left, we need to plug in less positive SCP value, which is plus 0.17 volt. So E0 cell is going to be how much? Plus 0.11 volt. Okay. So value is going to be plus 0.11 volt. So that's the end of first question. I hope it makes sense to you. Next question. Predict and explain the variation in the enthalpy change of hydration of the ions sodium, magnesium, and aluminum. So as the magnitude of positive charge increases, charge density increases, ionic radius decreases. from sodium ion to aluminum ion, magnitude of charge increases, ionic radius decreases, charge density increases, so strong electrostatic attraction, also called ion dipole attraction. So strong electrostatic attraction exists between ion and water molecule. So hydration enthalpy becomes more exothermic. In general, we conclude higher the charge density, higher the hydration enthalpy. Lower the charge density, lower the hydration enthalpy. Okay. Figure 2.1 shows the incomplete energy cycle. So first of all, these gaseous ions combine together to give 1 mole of ionic solid. That's lattice energy. When 1 mole of ionic solid is dissolved in large amount of water to give an infinite dilute solution, that's going to be standard enthalpy change of solution. So in line C, I'm going to write aqueous magnesium ion and aqueous chloride ion. Okay. Now look at this. These are the gaseous cation and anion dissolve in large amount of water to give aqueous cation and anion, which means change 2 is basically enthalpy change of hydration of cation and anion both. So complete the line C on figure 2.1, state symbols also. I'm done with that. Use both words and symbols to identify change 2 on figure 2.1. Okay. So enthalpy change of hydration since examiner is looking in words, so I'm going to write magnesium ion and chloride ion, and also examiner is looking for the symbol also, so I can write here hydration of magnesium ion plus hydration of chloride ion. Since we have 2 chloride in the formula, so it needs to multiply by 2. Okay. Use changes 1 and 3 as examples of how this should be done. That's easy. Next, calculate a value for the lattice energy of magnesium chloride by selecting and using appropriate data from 2.1. So in order to calculate the lattice energy, we can have 2 different sort of scenarios. First, we need to apply Born-Haber cycle, and second, we need to apply solution lattice energy and hydration enthalpy data, right? So let me find out first whether we need to apply bond cycle data or solution lattice hydration enthalpy data. So examiner has given us some sort of values. Examiner has given us formation, first ionization energy of magnesium, second ionization energy of magnesium, electron affinity of chlorine. What's missing here? What's missing here? Atomization of magnesium is not given. First of all, atomization of chlorine is not given. Bond energy of chlorine is not given, which means I cannot find the bond energy value from the data booklet because अब data booklet मिलती नहीं है. That indicates that we have a very limited data in order to apply the bond Haber cycle, which means we'll go for the other possible method in which I'm going to use standard enthalpy change of solution equals to minus lattice energy plus hydration enthalpy. So I'm going to use this formula in order to calculate the lattice energy because solution value is already given. Hydration of cation and anion is given, and we need to find out the lattice energy, which means because of incomplete data, because of incomplete information, I cannot apply the bond Haber cycle concept here in order to find the lattice energy. So in order to find this value, I'm going to use this formula because iski values hame already given hai. All right. So let's plug in the values in the formula. Solution of magnesium chloride is minus 155. We need to find out the value of lattice energy minus Le as it is. Hydration of cation is minus 1920. Plus hydration of cation is minus 1920. Anion is minus 364. Since we have 2 chloride ion in the formula, so it needs to multiply by 2. So lattice energy from here is going to be minus 2493 kilojoules per mole. डिफाइन एंट्रोपी को डिफाइन करने की बहुत सारी पॉसिबिलिटीज हैं. मैंने क्लास में बताया आपको disorderness of the system, in which dispersal of energy takes place. From system to surrounding, and vice versa. Okay. At 25 degrees Celsius, the enthalpy change of solution of compound Z is plus 26 kilojoule per mole, which means this is delta H. The entropy change of Z at the same temperature is this. Entropy change is basically in joules, whereas delta H is in kilojoules, which means we need to convert joules into kilojoules. And for that, I need to divide by 1000. All right. Calculate the value of the Gibbs free energy change for the reaction of Z at 25 degrees Celsius. By the way, 25 degrees Celsius converted into Kelvin. So I will add plus 273. I'm going to get 298 Kelvin, guys. Okay, so 273 plus 25 becomes 298 Kelvin. So let me apply the formula here. Delta G equals to delta H minus T delta S naught. Okay. Delta H is plus 26 minus 298. Entropy is plus 52. Since its value is given in joules, we need to convert it into kilojoules. So divide by 1000. So delta G for this reaction is going to be, hold on, 26 minus 298 bracket 52 bracket divided by 1000. So it's going to be 10.504 plus 10.504. The value is going to be plus 10.5 kilojoules per mole. Okay. Let's move on to the next part. Use your answer to D to predict whether or not Z is soluble in water at 25 degrees Celsius. Explain your answer. Since delta G is positive, which means reaction is not feasible, which means it is not soluble in water. Okay. It is insoluble in water. As delta G naught value is positive, which means reaction is not feasible. Or spontaneous. All right. Next is predict whether Z becomes more or less soluble as water is heated from 25 degrees Celsius to 95 degrees Celsius. Explain your answer. So we have delta G naught equals to delta H minus T delta S. Delta H value was positive, minus T will remain. Delta S naught value was positive also, right? Look, delta S value is positive, delta H value is positive, both the values are positive, right? So what we can do is this positive will remain as it is. This minus plus becomes minus. Okay, so delta G could be positive, could be negative. So I'm increasing the temperature from 25 degrees Celsius to 95 degrees Celsius. So if I'm increasing the temperature, obviously the entire T delta S naught term becomes more negative, and so delta G becomes negative. And if delta G becomes negative, reaction is going to be feasible. If reaction is going to be feasible, obviously Z is more soluble in water at high temperature. Okay. Within 2 lines and with for 1 mark, how can I write the entire information? Delta H and delta S both are positive. So increase in temperature makes T delta S naught term becomes more. Big T delta X term becomes more. Hold on. Okay. Term becomes more negative. So delta G naught is negative. Hence reaction is feasible. Or spontaneous. That's the end of second question. I hope it makes sense to you. Let's move on to the third one. Question number 3. The pH of a saturated solution of calcium hydroxide is 12.36 at 298 Kelvin. So value of pH is given. Examiner is looking for the concentration of hydroxide ion in a saturated solution of calcium hydroxide. Is 0.0244 mole per dm cube at 290 Kelvin. So I need to show, which means I need some sort of working here. So working is easy. pH plus POH equals to 14. First, we need to find out the value of POH. And for that, I'm going to subtract 14 from 12.35. So POH is going to be how much? 14 minus 12.35. So that's 1.65. Now from this POH value, I can find the concentration of hydroxide ion by using this formula. POH is 1.65 minus log concentration of hydroxide ion. So concentration of hydroxide ion is going to be shift log minus 1.65. It's going to be 0.02238 mole per dm cube. So इसको राउंड ऑफ करेंगे तो हमारे पास वैल्यू बनेगी 0.0224 mole per dm cube. Hence proved. Okay. Now the next is use data given in 1 to calculate the solubility product of calcium hydroxide at 298 Kelvin. Include the units of KSP in your answer. So I know the concentration of hydroxide ion. Okay. First of all, let me write the ionic equation for the dissociation of calcium hydroxide. Okay. Now look at this. Both of them has 1:2 ka ratio. If the concentration of hydroxide ion is 0.0224 mole per dm cube, the concentration of calcium ion would be its half divided by 2. It's basically 0.011112 mole per dm cube. So I know the concentration of calcium ion. I know the concentration of hydroxide ions, which means I can find the value of KSP by plugging the value in the formula. So let's introduce the value in the formula. In order to calculate the KSP of calcium hydroxide, the formula is concentration of calcium ion, concentration of hydroxide ion. Since hydroxide has 2 moles, so number of moles has to be in power. Concentration of calcium ion is 0.0112. Concentration of hydroxide ion is 0.0224, and it's a square. So concentration 0.0244 square into 0.112. It's 6.66 into 10 to the power. मेरे पास 6.66 into 10 to the power minus 5 आ रहा है. Let me check my values again. 0.0244. Oh, sorry. 0.0224 square करें. Multiply by 0.0112. That's 5.61619 into 10 to the power minus 6. Okay. So after rounding of the value, it's going to be 5.62 into 10 to the power minus 6, and unit is going to be mole cube dm minus 9. I hope it makes sense to you. Since it is mole per dm cube, it is mole square dm minus 6. So if 2 units are multiplying together, we can add the powers, right? Units add हो जाती हैं, जिसकी वजह से ये value आई. A spatula measure of solid calcium chloride is stirred into a sample of saturated calcium hydroxide solution. All of the calcium chloride dissolves. Describe one other observation that would be made and give an estimated value of the pH of the solution obtained. So examiner is technically looking for one other observation, and examiner is looking for the estimated value of the pH, not the exact, the estimated. And estimated means you can make any sort of range, okay? You can give the range value. You can give the value in a possible range actually. What's happening here actually? Let me draw a beaker here. Yeah, let me draw the beaker here. We have calcium ions and hydroxide ions because it is a saturated solution of calcium hydroxide. When we add calcium chloride in it, obviously the concentration of calcium ion in a saturated solution increases. So when concentration of calcium ion increases, this favors the equilibrium towards left-hand side because of the common ion effect. And when equilibrium favors towards left-hand side, obviously calcium hydroxide is formed. That was the equation. Okay. So this is a saturated solution of calcium hydroxide in the beaker. When you add calcium chloride in it, obviously the amount of calcium ion increases. If amount of the calcium ion increases, it reacts with hydroxide ion, converting into calcium hydroxide. So because of common ion effect, equilibrium favors towards left-hand side. As a result, precipitates of calcium hydroxide increases. So white precipitates are observed. pH of solution. Since this solution has calcium chloride and calcium hydroxide both, so that means pH exists between 7.2 to 14. I mean, it's a weak alkali, so it has to be greater than 7.2. Okay. Explanation. When aqueous calcium chloride is added, due to common ion effect, concentration of calcium ion increases. This favors equilibrium towards left-hand side. Okay. Hence, precipitation increases. Which is why आपको precipitates observe हुए थे. Next, calcium hydroxide reacts with dilute sulfuric acid to form calcium sulfate. The equation for this reaction is to be like this. Calcium hydroxide plus H2SO4 will turn to calcium sulfate and water. Barium hydroxide behaves in a similar way, forming barium sulfate. Explain why calcium sulfate is more soluble in water than barium sulfate. So that's because of the charge density and lattice energy and hydration enthalpy. So what we can say is calcium ion has a smaller radius, smaller ionic radius than barium ions. So lattice energy and hydration enthalpy both increases. All right. Not increases, both decreases down the group. Or down the trend. But lattice energy play a key role because of the smaller ionic radius of hydroxide ions. So lattice energy decreases more significantly than hydration enthalpy. No. It's sulfate. My bad. My bad. Hold on. But hydration energy decreases more significantly than lattice energy. Oh my goodness. Hydration enthalpy decreases more significantly than lattice energy. Hence, solution becomes, standard enthalpy change of solution becomes endothermic. And if solution is endothermic, obviously solubility decreases. Hence, barium sulfate is insoluble. Then calcium sulfate, okay? My goodness, you have to be very, very careful. You need to consider calcium sulfate and barium sulfate only, okay? Next, part B. Some solid calcium is added to excess aqueous ethanoic acid. First of all, aqueous ethanoic acid means ethanoic acid is placed in water, converting into H3O plus and ethanoate ions. Okay. Second thing, calcium has reacted with this acid. So this ethanoic acid, when react with calcium, obviously calcium ethanoate is formed. And hydrogen gas is given off, all right? And by the way, this calcium ethanoate is a salt. It is soluble in water. Write an equation for the reaction of calcium with ethanoic acid. That's easy. 2 moles of ethanoic acid reacts with 1 mole of calcium. converting into 2 moles of calcium ethanoate and hydrogen gas. One more thing. Ethanoate ions has -1 charge. Calcium ion has 2 plus charge. According to O-level chemistry, if charges are different, they need to cross multiply with each other. So if you cross multiply these charges, the formula is going to be like this. Okay. Next, use formulae of molecule and ions to identify 2 conjugate acid base pairs. Examiner is looking for 2 conjugate acid base pairs present in the mixture D. So this is the mixture actually. This is all the mixture. So this mixture make conjugate acid. इसमें conjugate acid is H3O plus. And conjugate base is ethanoate ions because it is negatively charged. Pair 2. No, it's not like that. If conjugate base is ethanoate ions, obviously this must be ethanoic acid because दोनों एक दूसरे के corresponding होते हैं. So if it is a conjugate acid, obviously it will give you conjugate base. Similarly, conjugate acid is H3O plus. So conjugate base is what? H2O. Because it is proton donor, it is proton acceptor, which is why it is conjugate base, it is conjugate acid. That's what I think actually. Yeah. Yeah. In the first equation, this is acid and this is going to be conjugate base. In the second pair, this is base and this is conjugate acid. Conjugate acid is a proton donor, so it donates its proton. Conjugate base is a proton acceptor, so it accepts proton. Okay. Write an expression for Ka of methanoic acid. So concentration of methanate ions, concentration of hydrogen ions, and concentration of methanoic acid. Okay. Oh, that's easy. We have done this in class. The concentration of calcium ethanoate in mixture D is 0.394 mole per dm cube. The concentration of ethanoic acid is this. The Ka of this, calculate the pH of this. By the way, this is salt and this is acid. So concentration of acid and concentration of salt already given in the question. Ka of ethanoic acid is given in the question. So from this Ka, I can find the value of pK. Let me find the value of pK equals to minus log Ka. So Ka is basically 1.74 into 10 to the power minus 5. So value of pKa is going to be how much? Minus log 1.74 exponent minus 5. So it's going to be 4.76. 759. So it's going to be 4.76. Now I'm going to apply the Henderson equation. And this Henderson equation is applicable for the buffer solution. Because the concentration of salt and acid is given, which means it's a buffer solution, acid buffer solution. So I need to apply the Henderson equation. pK is 4.76 minus log. Concentration of acid is 0.270. Concentration of salt is 0.394. So the pH is going to be how much? hold on, 4.76 minus log bracket 0.270, so double bracket 0.270 divided by 0.394. So the value is going to be 6.203. So pH is basically 6.2. Let me check my calculation again. 0.270 divided by 0.394. 0.6 log answer. It's 4.76 minus answer. 4.92. How come 4.92? Hold on. 0.270. Log answer. 4.76 minus answer. I've got the wrong value actually. Let me check my calculation again. 0.270 divided by 0.394 is going to be 4.76 minus log 0.685. 4.76 minus log answer 0.849 plus 4 plus 4.74. Oh, sorry, 76. 5.60. Yeah, that's fine. pH equals to 5.61. 609. So it's going to be 5.1. 5.61. Okay. That's my answer. Write two equations to show how mixture D can act as a buffer solution. Whew. So salt is ethanoate ions. Salt is a conjugate base. It always accepts proton, which is represented by H plus sign, will turn into ethanoic acid. Now this ethanoic acid, when we have added hydroxide ions, will turn to salt and water. We have done these equations in the class. Guys, let me check my values again. 0.270 divided by 0.394. I'm sure the answer सही होगा, but 0.685. So minus log answer. Minus log 0.685 plus 4.76. My goodness, every time I'm getting the different answer. Minus log 0.685. Wait a minute, minus log 0.685. Bracket close. Plus 4.76. I don't know, I'm getting different answers. Something happened with my calculator, I think so. Yeah, something happened with my calculator. I don't know. Every time I'm getting different calculation because something happened with my calculator. Minus log 0.685. My goodness, How come 0.849 plus 4.76? I'm getting 4.92 now. I don't know. Hold on. 0.270 divided by 0.394. I'll get this amount. 0.685. Okay. Now minus log answer. I'm getting different answer actually every time. Anyhow, you can check this calculation, guys. The format is fine, but you need to check the calculation again on your calculator. Okay. Whatever I'm getting on my calculator, I'm just writing it, okay, for your reference. So make sure you need to check the calculation again. Rest is fine, but you need to check the calculation from your calculator. Something happened with my calculator. I don't know why. Let's move on to the next question. Question number 4. Transition metal atoms and transition metal ions form complexes by combining with the species called ligands. Ligands lone pair donors को कहते हैं. When NaOH is added to an aqueous solution containing cobalt-2 ions, a precipitation reaction occurs accompanied by a color change. Okay, this cobalt-2 ions has a blue color. When it is treated with NaOH, pink precipitate, bluish pink precipitates are formed. Okay, in this reaction, 2 of the water ligand each loses 1 hydrogen ion. The hydrogen ion are gained by hydroxide ion from the NaOH. And that's what I have told you in the class. That's the mechanism we have discussed regarding this reaction. Okay, you have done that mechanism with me in the class. Okay, if you remember, let me show you what we have done in the class. That was cobalt ion, first water molecule, second water molecule, third water molecule, fourth water molecule. This one is fifth, and that one is sixth. Now this hydrogen is slight positive. This hydrogen is also slight positive. Now you have 2 hydroxide ions. So this hydroxide react with this. This hydroxide accept this proton and converting into 2 moles of water. So examiner is saying this. Okay. Next, this cobalt will turn to like this. After the removal of hydrogen ion, only hydroxide ions or OH group left. So that is the whole scenario. That is the whole mechanism we did in the class. Okay, that's an acid-base reaction because it donates its proton. It is accepting protons. So it is an alkali. It is an acid. So it's an acid-base reaction, also called precipitation reaction. That's the whole concept we have done in class. So let's state the color change in this precipitation reaction from blue to bluish pink. Okay. Complete the ionic equation for this precipitation reaction. That's easy. 2 moles of hydroxide ions converting into 2 moles of water plus cobalt ions. We have 4 water molecule left. As you can see in the structure, we have 2 hydroxide ions left. Okay. The precipitation reaction can also be described as a different type of reaction. Name this type of reaction. I said acid base because it is an alkali. It donates its proton, which is why it is an acid. So acid base reaction. L is an uncharged tridentate ligand. That means this tridentate ligand, uncharged means neutral ligand, and tridentate means one ligand donate 3 lone pairs so that 3 dative bonds are formed. Okay, that's exactly examiner's statement. Okay, my bad. Cobalt forms octahedral complex. Octahedral complex means coordination number is 6. Coordination number is also called fold number. So fold number is 6. And complex has a charge of 2 plus. The formula of E, that's easy. Well, one L forms 3 covalent bonds. In order to make 6 bonds, I need 2 L. So it's basically, I can write in this way, COL2. And overall charge is 2 plus. Okay, because L is a neutral ligand, it has no charge. Identify the oxidation state of cobalt in E 2 plus. Because L is neutral. So जो भी charge होगा यहाँ पर, that represents the oxidation state of cobalt. Okay. The d orbital of cobalt atom or ion present in E splits in energy. State the number of d orbitals that are at higher energy level. That higher energy level is represented by T2G as per my lecture. And that contain dx squared dash y squared and dz squared, which means in total we have 2 energy levels. And the number of d orbitals at a lower energy level. The lower energy level in the class I have represented by Eg, and that contain dxy, dxz, dyz. So in general, we have 3 energy levels, right? And define the term non-degenerate d orbitals. By the way, degenerate d orbitals have equal energy. So if we talk about non-degenerate, which means orbitals have different energy. So d orbitals have different energy. Okay. Next, part C. The mineral chromite contains a compound which is a formula this. The oxidation state of iron in this is +2. Oh my goodness, that's important. A sample of 4.1 gram of this compound, so mass of the sample is given, is dissolved in excess sulfuric acid. The resulting solution is made up to 250 cm cube. That's important. 25 cm cube of this solution F, which contain iron 2 ions, are oxidized into iron 3 ions by exactly 18.7 cm cube of 0.02 mole per dm cube KMnO4. 1 mole of manganate ions react with 5 moles of iron 2 ions. Write an equation for the reaction of Fe2 plus with manganate ions in acidic solution. Since there is no data booklet is given, which means either you need to memorize this equation or you need to balance the equation by using ion electron rule. And ion electron rule we have done in the class both in AS and in A2. So I'm going to write the equation as it is. MnO4 negative converting into Mn2 plus. See guys, manganese is 1 mole on both the sides. We have 4 oxygen. So to balance oxygen, I'm going to write 4 water molecule. So to balance hydrogen atom, I'm going to write 8 hydrogen ions here. Okay. I need to mention iron 2 ions also. And these iron 2 ions are technically converted into iron 3 ions. So guys, we need to balance the charge. Over here, we have 2 plus charge. Over here, we have 7 plus charge. So I'm going to write 5 here and 5 here. Now look at the charge now. 5 times 2, 10 plus, 10 plus and 8 plus, 18 plus, 18 plus and minus 1, 17 plus. Look at the charge here. 5 times 3, 15 plus, 15 plus and 2 plus, 17 plus. So charge on both the sides are balanced, which means it's a balanced chemical equation. Calculate the number of moles of Fe2 plus ions in 250 cm cube of solution. Whew, okay. So I know the concentration and volume of KMnO4, which means first of all, I need to find out the moles of KMnO4. Okay. And moles of KMnO4 and manganate ions is the same thing. So it's 0.02 into 18.7 divided by 1000. 0.02 into 18.7 divided by 1000. So it's going to be 3.74 into 10 to the power minus 4 moles. That is my first step in this calculation. We need to find out the moles of Fe2 plus. So we know that manganate ions and iron 2 ions exist in 1:5 ratio. If we have got 3.74 into 10 to the power minus 4 moles, so moles of Fe2 plus ions multiplied by 5 is going to be 1.87 into 10 to the power minus 3 moles. Okay. Calculate the MR of this and use your answer to reduce the value of N. Oh my goodness, that's excellent. So I've got the moles in 250 cm cube. And so how much moles we have in 250 cm cube? 25.0 cm cube contain how much moles? Hold on. 1.87 into 10 to the power minus 3 moles. Yeah. Then in 250 cm cube, moles would be into 250 divided by 25. So technically 10 times dilution over here, so it's going to be 0.0187 moles. Fe2 plus. Formula is FeCrNO4. So in this formula, we have iron 2 ions. Both of them has 1:1 का ratio. तो जो भी moles हैं आपके पास iron 2 ions के, exact वही moles इस sample के भी हो जाएंगे. The mass of sample is already given. So I can find the MR. Mass is basically how much? 4.18 gram. Divided by moles. Moles is 0.0187. So MR is going to be 4.18 divided by answer. MR is going to be 223.5. Okay, we need to find the value of N, and for that we can start another FeCrNO4 equals to MR. Now take out the mass of iron and oxygen. Iron is 55.6, I believe. Let me check from the periodic table. 55.5 or 55.6. I think it's 55.8. Okay, 55.8. 55.8 plus N chromium plus 16 times 4 equals to 223.5. So 16 times 4, 64 plus 55.8 is basically, so N chromium plus 119.8 equals to 223.5. So N chromium equals to 223.5 minus 119.8. 223.5 minus answer. So I'll get 103.7. And chromium. Now chromium has a mass of how much? I think it's 52. Let me check again. Chromium has a mass of 52 exactly. Okay. $52 equals to 103.7. So in order to get the value of N, I need to divide this by 52.0. So value of N divided by 52. So value of N is basically 1.99. So round off होकर ये value 2 हो जाएगी. And MR is going to be 223.5. I hope it makes sense to you. ये हमने कैसे calculate किया? That's the end of this question number 4, I believe. Let's move on to the question number 5. This question is again from the transition element, guys. Examiner's favorite. Nickel 2 ions forms a number of different complex ions, including this complex, ammonia, and En. Okay. Both of them are monodentate ligand. This is bidentate ligand. Complexes which are formed through bidentate ligands are more stable than the ones which are formed through monodentate ligands, which means the stability constant of this complex is far greater than these two complexes. First thing. Second thing, according to spectrochemical series, which we have discussed in the class, ammonia is a stronger ligand than water, which means complexes which are formed through ammonia ligand are more stable than the ones which are formed through water, which means the stability constant of this complex would be greater than this one. So the highest stability constant belongs to this complex and the lowest stability constant belongs to this complex. All right, let's start with the question again. The abbreviation En represents ethylene diamine, which is also called 1,2-diaminoethane. The numerical value of the two stability constants are given in the table. Look at the explanation. This is the highest stability constant and this one is the lowest one. So examiner has given these two. Okay, let me check one thing. Let's draw the equation first. This is aqueous nickel 2 ions. All right. Now, En is a bidentate ligand. So one bidentate ligand forms 2 dative bonds, right? In order to make 6 dative bonds, I need 3 bidentate ligand, which means I need 3 En. En is a stronger ligand than water. Ligand substitution reaction takes place, or also called ligand exchange reaction takes place. And as a result, you will get En taken 3, 2 plus, and this is 6 water molecule. So in order to write the stability constant, I'm going to ignore water. Rest, I'm going to write it. This is the coordination sphere. So nickel, En taken 3, 2 plus, divided by nickel, NH3 taken 6, 2 plus, charge has to be inside the bracket, if you remember. Then concentration of En power Q. A solution of aqueous nickel ions is added to solution that contain 0.1 mole per dm cube ammonia and 0.1 mole per dm cube En. Now concentration of both ammonia and En are same. Predict which complex ion is present in the resulting mixture in the highest concentration? Explain your answer. Obviously, complex with En ligand, because its stability constant is greater than this. Oh, explanation. Because its concentration oh my goodness, not concentration. Because okay, इसको इस तरह से लिखें कि step value of nickel En taken 3 2 plus is greater than the value of nickel NH3 taken 6 2 plus. Okay, complete the equation for the ligand exchange reaction occurring in 1 1 1 1 1 1 1 में क्या हो रहा है 1 में क्या हो रहा है so basically ये वाली इक्वेशन आएगी this one. Okay, so ये हो जाएगा 3En, ये हो जाएगा निकल En taken 3 2 plus 6 water molecule. Okay, यही तो हो रहा है, यही तो हो रहा था कि बेटा ये रिएक्शन कर रहा था इन दोनों में से, तो हमने ये डिसाइड कर लिया कि भाई En ज्यादा स्टेबिलिटी कांस्टेंट है तो वो प्रायोरिटी पर रिएक्शन करेगा, और हमने इक्वेशन भी उसी को देखते हुए यहां पर बनाई है. ठीक है, नेक्स्ट, complete figure 5.1 to show the three-dimensional structure of the two isomers. Look at this example. This complex has 3 bidentate ligands. So whenever we have 3 bidentate ligands, we can have optical isomerism in which we need to get the mirror images. Okay, so first of all, let me draw the dotted and pyramid to make the 3D diagram. Pyramid is basically the out of the plane, dotted line is basically behind the plane. I believe you have an idea of this. Okay, so En is represented by this symbol. That's easy, we have done this in class. This is N, this is N, this is N, this is N also, this is N, this is N. Now N, N, ये भी N है, ये भी N है, N, N, N. Okay, so that's the mirror images, types of isomerism, optical isomerism. End of question number 5. Let's move on to the question number 6. Oh my goodness. Figure 6.1 shows 2 reactions of ethane dioic acid. Ethane dioic acid is basically a dibasic acid because it donates 2 hydrogen ion in aqueous medium. And by the way, it is acting as a reducing agent for some reactions also. Okay, so when you react thionyl chloride with ethane dioic acid, you will get ethane dioil chloride like this. And when you react this compound with certain reagent, obviously carbon dioxide water is formed. So removing carbon dioxide is basically, technically we are converting ethane dioic acid into carbon dioxide. So we need an oxidizing agent in the presence of an acidic medium. Okay. Draw the organic product G in the box in figure 6.1. In figure 6.1, SOCl2 gives as the reagent that reacts with this to produce G. Identify a different reagent. In place of thionyl chloride, I can use phosphorus pentachloride, PCl5. Identify two different reagents that oxidizes this into carbon dioxide and water. Examiner is looking for the two different oxidizing agents. So I believe the first one is K104 in the presence of acidic medium. The second one is K2Cr2O7 in the presence of acidic medium. That's my first, that's my second, and that's my third. Oxygen, because oxygen is an oxidizing agent also. And this basically compound is a reducing agent, so it can react with an oxidizing agent. Okay. Ethane dioic acid ionizes as shown. Okay, donates one hydrogen ion in aqueous medium. This compound is much stronger acid than methanoic acid. Suggest an explanation for this difference in acidity. We have done this whole scenario in ionic equilibria chapter. All right. So dibasic acids are stronger than monobasic acid. First point. Now look at the structure of ethane dioic acid. It is electron withdrawing group. So when it withdraw the electrons, obviously this carbon becomes electron deficient. To neutralize the positive charge of carbonyl carbon, it pulls the electron from oxygen atom, making oxygen electron deficient. And obviously, to neutralize the positive charge of oxygen, it pulls the electron from hydrogen, and as a result, hydrogen removes in the form of hydrogen ion. So technically, this entire group is basically this entire group has a negative inductive effect, so it pulls the electron towards itself, makes the ionization of hydrogen easier. My goodness, that's tricky explanation. So COOH group has a negative inductive effect. So this makes the ionization ion becomes easier. And according to my lecture, its anion stabilizes more. Its monoanion stabilizes also. Why? Look at the structure. This is COOH. This is COO negative. Why I'm saying this? Let me show you. We have done this whole sort of concept in the class. Okay, look. This entire group is electron withdrawing group. So when it pulls the electron towards itself, obviously this carbonyl carbon becomes electron deficient. So neutralize the positive charge. ये negative charge यहाँ पर bond बनाएगा. ये pi bond is oxygen पे shift होगा, which means this charge exhibit resonance process because of this negative inductive effect of carboxylic functional group. As a result, this oxygen becomes negatively charged और यहाँ double bond आ जाएगा. फिर क्या होगा? ये negative charge यहाँ पर bond बनाएगा, यहाँ शिफ्ट होगा. तो इसका मतलब रेजोनेंस की वजह से ये दोनों स्ट्रक्चर एक दूसरे में कन्वर्ट होते रहेंगे. एंड सिंस रेजोनेंस जहां पर भी होती है वहां स्टेबिलिटी ज्यादा हो जाती है, which is why this group increases the stability of the anion, which is why acid is stronger. Okay. I hope it makes sense to you. Benzene 1,4 dicarboxylic acid can be made from benzene in two steps as shown in figure 6.2. So मैं आपको पहले ही कह चुका हूं कि COH डायरेक्टली अटैच नहीं हो सकता. In order to attach COH, benzene needs to have to be undergone in alkylation process. Okay, so we need to convert CH3 into COH. Okay, so I believe this must be CH3 and this must be CH3. So this CH3 will turn to COH and this CH3 will turn to COH. Okay, so first step is basically alkylation, and since I'm adding only CH3, which means CH3Cl is going to be the reagent and condition is going to be AlCl3, which acting as a catalyst. Step 2 is oxidation, and for that I need oxidizing agent. So to convert CH3 into COH, I'm going to use KMNO4 in the presence of acidic medium. Identify the reagents and conditions and suggest the identity of J by drawing its structure. I've done that. Step 1 is simple. CH3Cl is the reagent. Condition is anhydrous AlCl3, which acts as a catalyst. Okay. Step 2 is acidified KMNO4. And obviously I need to heat under reflux. Okay. Draw the structure of exactly one repeating unit of the polymer formed when 1,4-benzene dicarboxylic acid react with ethane 1,2-diol. The linkage formed between the monomers should be drawn fully displayed. Okay. Let me show you one thing. This is benzene 1,4-dicarboxylic acid. And this is 1,2-diol. Ethane 1,2-diol, I mean to say. Okay. So what we have discussed in the class that in order to make an ester, carboxylic acid से OH जाएगा, alcohol से H, and as a result water is formed. यहाँ से भी OH जाएगा, यहाँ से H जाएगा. So I can write this structure like this: C double bond O, C double bond O, this oxygen, this CH2, this CH2, this oxygen, and this bond continuation. Okay. So that's the one repeating unit, guys. From here to here, that's one repeating unit. If the same structure, I can draw it, that's called the repeating unit. I mean, that's the ester linkage. So what we have got from here, that carboxylic acid loses OH and alcohol loses H. From here, alcohol se H jayega, and from here, carboxylic acid se OH jayega, and I'm going to make this structure without any issue. I hope it makes sense to you. State the type of polymerization occurs when this two reagents react together. Obviously, condensation polymerization, and the linkage is polyester linkage. That's easy stuff. Polyester or just ester. Okay. Question 6 done. Let's move on to the question number 7. Benzene reacts with chlorine gas to form chlorobenzene. The reaction can be described as the reaction between benzene molecule and Cl+. The Cl+ are formed by adding a suitable catalyst to the chlorine gas. Give the name or formula of the catalyst that can be used in this anhydrous AlCl3 aluminum chloride भी कह सकते. Okay. The mechanism of this reaction is shown. Okay. The movement of a pair of electrons is represented by X in diagram 1. State where this pair of electron is before step 1 takes place. Pair of electron actually exist with the pi electrons or in the pi bonds. Okay. Before reaction start होने से पहले कहाँ थे? Pi bonds में. So state where this pair of electron is after step 1 has taken place. After technically carbon and chlorine, right? इसको इस तरह से लिख सकते हो, pi bond of the benzene ring. And after that reaction, carbon chlorine bond में exist करेगा ये. ठीक है? The movement of another pair of electron is represented by Y in diagram 2. State whether this pair of electron is before step 2. Step 2 that exists between carbon and hydrogen. Exist in CH. Now the next part is state whether where this pair of electron is after step 2 has been taking place after. So this bond shifts into the ring so that ये pi bond complete हो जाए. So obviously what we can say is to make the pi bonds, of the benzene ring. Okay. There are 6 carbon atoms in diagram 2. State how many of these carbon atoms are sp hybridized, sp2 and sp3 hybridized. So whenever we have triple bond, sp hybridization hogi. There is no triple bond in this diagram. That means sp hybridized is 0. sp3 is single bonded. We have only one single bonded carbon atom. So this carbon is sp3 hybridized. How many sp2s? Jahan jahan bond hai wahan sp2. This one, this one, this one, this one, and that one. So 1, 2, 3, 4, 5. So 5 carbon has sp2 hybridized. Okay. Part B, complete the equation for this reaction between benzene and chlorine. That's easy. When chlorine and benzene react together, you will get chlorobenzene, which is C6H5Cl. And obviously, you will get HCl also. We have done this in the notes, all right? The mechanism for this reaction is electrophilic substitution. Complete the following sentence. Write formula in the gaps provided during this reaction. The electrophile is Cl plus and a hydrogen atom in the benzene ring is substituted by chlorine atom. Okay. Chloroethane reacts with NaOH. Chlorobenzene does not. Name the mechanism of the reaction that chloroethane undergoes with NaOH and identify the major organic product that is formed. Mechanism is nucleophilic substitution reaction. Whew. Chloroethane, when treated with NaOH, the major organic product would be ethanol. That's easy. That's what we have done in AS. Explain the difference in reactivity of chloroethane and chlorobenzene when treated with NaOH. First of all, chlorine, not chlorine, lone pair of chlorine is delocalized with a pi bond is delocalized with a pi bond of benzene. So due to which carbon chlorine bond in chlorobenzene is stable and unreactive. All right. Hence, reaction cannot take place. I'm done with the question number 7. Let's move on to question number 8. Question number 8. Question number 8. Question number 8. Okay. Question number 8. The amino acid serine exists in two optically active forms. If serine exhibits optical isomerism, it's because of the fact that it has a chiral carbon atom, and that chiral carbon atom is represented by this steric. All right. And both of them are mirror images of each other also. Isomer P and isomer Q have identical physical and chemical properties with the exception of two specific properties. One of these two properties is their differing effect on the plane polarized light. Obviously, one is dextrorotatory, one is levorotatory, and both of them have different rotations of plane polarized light. State the other property in which they differ. Obviously, dextro and levo have different biological activities also. Both dextrorotatory and levorotatory isomers have different biological activity. Okay. This dextrorotatory isomer is represented by plus D. This levorotatory isomer is represented by minus L. मैंने क्लास में आपको बात समझाई थी कि जैसे ग्लैक्सोज D होता है, तो that D is basically dextrorotatory. ठीक है. So दोनों का जो बायोलॉजिकल एक्टिविटी है वो डिफरेंट होती है. ओके. और डेक्स्ट्रो ग्लैक्सोज डी या ग्लूकोज डी तो हम डेली लाइफ में यूज भी करते हैं बेटे. A solution of pure isomer P of a particular concentration rotates plane polarized light by 50 in a clockwise direction. That's dextrorotatory isomer. When the plane polarized light rotate in a clockwise direction, that's called dextrorotatory. If it is anti-clockwise, that's called levorotatory. So describe how a solution of pure isomer Q of the same concentration affect plane polarized light. Obviously, plane polarized light rotates with an angle of -5 degrees because it's moving in the anti-clockwise direction. So yeah, no. Plane polarized light with an angle of 5 degrees in anti-clockwise direction. Okay. State another term in addition to the stereoisomers, optical isomers, and non-superimposable mirror images, which can be used to describe the pair of chiral compounds, isomer P and isomer Q. That's what I've told you. कि एक आपका है इसमें से dextrorotatory, एक laboratory, both D and L are mirror images of each other, and दोनों को मैंने A1 chemistry में कहा था enantiomers of each other. So I'm going to write enantiomers. Next, give the term used to describe the mixture containing equal amount of isomer P and isomer D. I've told you if we have 50% dextrorotatory isomers, and if we have 50% levorotatory isomers, obviously this sort of mixture is called racemic mixture, जिसको हमने A1 chemistry में equimolar mixture लिखा था. But in A2, I'm going to write racemic mixture. Okay. और मैंने ये term use की है A1 chemistry में, ठीक है? Describe one way in which a single pure optical isomers of serine can be produced instead of making a mixture of this. अगर mixture नहीं बनाना चाहते, single isomer बनाना चाहते हैं, तो उसके लिए आपको chiral synthesis की तरफ जाना पड़ेगा. So use chiral catalyst to synthesize single pure optical isomer. Okay. Oh my goodness. Let's move on to the next part of the question. God. Complete table 8.1 to describe the peaks seen in the proton NMR spectrum of this compound dissolved in D2O. Let me write the structure first. This is CH. This is CWH. This is NH2. And this is CH2OH. Okay. So first of all, how many peaks we have? In the proton NMR spectrum, we have first peak, second peak, third peak, fourth peak, and this one is fifth peak. So we have 5 peaks in total, which means we have 5 chemical environments. Okay. Okay. Group responsible for the peak. Okay. So first of all, CWH. Name of a splitting pattern, singlet hogi. Apply n+1 rule here. So 0 plus 1, you will get 1, and that will give you singlet. Okay. Then this peak, n+1, 0 plus 1, again singlet, and this singlet represents OH. All right, let's talk about this one. This carbon has 1 proton in its neighbor, so it gives you doublet. CH2 group is going to be responsible because it contains 1 hydrogen in its neighbor carbon. Okay. Let's talk about this carbon. This carbon has 2 hydrogen atoms. So if I'm going to apply n+1 rule, it's going to be triplet. So triplet is basically CH, And NH2 also. Let me show you something. Let me check. There is no NMR data is given. I mean, how can? Oh, oh my goodness, there is no NMR data. Oh my goodness. Oh my goodness. Oh my goodness. Let me check. Oh my goodness, that's very different sort of question. Without giving any, this is NH2, and again it is singlet. Okay. So मतलब इसको arrange नहीं करना आपने in terms of chemical shift. You just need to write these groups. All right. If it is triplet, obviously neighbor carbon atom or adjacent carbon has 2 hydrogen. If it is doublet, adjacent carbon atom has 1 hydrogen. Okay. If it is singlet, it is also singlet. It is singlet. So, N+1 rule are not gonna apply. Same N+1 rule are not gonna apply because neighbor carbon has no hydrogen atom. I can also write failure of N+1 rule. My goodness. Proline is a naturally occurring amino acid. The skeletal formula of proline is shown. State the number of peaks in the carbon 13 NMR spectrum of proline. So proline में कितनी peaks होंगी? 1, 2, 3, 4, 5. 5 peaks होंगी. So this one is first. This one is second. This one is third. This one is fourth. And this one is fifth. Okay. आप इसको इस तरह से भी कर सकते हैं. 1, 2, 3, 4 and this one is 5. Okay. आप इस ऑर्डर में भी दे सकते हैं, बट होंगी वो 5 peaks. Next, glutamic acid is another amino acid. The skeletal formula of glutamic acid is given. Okay, that's the skeletal formula of glutamic acid. Again, this carbon is chiral carbon. The isoelectric point of glutamic acid is pH 3. By the way, isoelectric point when no net electrical charge exists. Okay, and its pH value is given. Isoelectric point of glutamic acid is given. A sample of glutamic acid dissolved in a solution of pH 1. A strong alkali is then added and the pH of the mixture reaches to pH 14. Strong alkali, pH 14. During this process, all possible ionized forms of glutamic acid are present at different times depending on the pH of the solution. Complete the boxes below to show 4 different ionized forms of glutamic acid that are present in the stated pH values. In 1, in 14. So, अगर isoelectric points की value कम हो, अगर pH of buffer is greater than isoelectric point, तो COH जो है वो deprotonate होता है. So, oh my goodness, pH 1 पे क्या होगा? So pH 1 पर मीडियम एसिड होगा तो ये NH2 प्रोटॉन एक्सेप्ट करेगा. That's the only thing I can expect. This is NH3 plus, Cl minus. Okay. Since pH 1, so acidic solution. An acidic solution shows the presence of hydrogen ion. Okay. At pH 3, obviously, isoelectric point और pH 3 ये दोनों same हो गए. So obviously zwitterionic form में exist करेगा. That means कि COOH और ये NH2 internal acid base reaction में चले जाएंगे, and as a result you will get zwitterionic form. This is going to be NH3 plus, and this is going to be COO negative. So it is zwitterionic form because ये plus is minus को neutralize कर देगा, तो technically no net charge at pH 3. Okay. Oh god, pH 9, medium is alkaline. If medium is alkaline, obviously ये दोनों protonate हो जाएंगे. I mean deprotonate हो जाएंगे. pH 9 is a weak base. Weak base ये भी deprotonate हो सकता है, ये भी deprotonate हो जाएगा, दोनों भी हो सकते हैं. दोनों नहीं होंगे because pH is 9. Okay, low pH है. So इसका मतलब इन दोनों में से किसी एक को दिखा दीजिए deprotonate होते हुए. All right. And pH 14 पे दोनों deprotonate हो जाएंगे. That's a very different sort of question. Very, very different question. दोनों deprotonate हो गए तो जाहिर सी बात है ये नेगेटिव होगा और ये भी नेगेटिव होगा. ओके. Again H2H2. So pH 1 के ऊपर सिर्फ NH2 प्रोटोनेट होगा बिकॉज स्ट्रॉन्ग एसिड है तो वो इजीली प्रोटॉन कर लेगा. pH 3 के ऊपर आइसोइलेक्ट्रिक पॉइंट और pH ऑफ बफर दोनों सेम हो गई है तो एग्जिस्ट एज ज्विटराइन. अब ज्विटराइन बनाने के लिए या तो आप इन दोनों को कर दीजिए ज्विटराइनिक फॉर्म में या इन दोनों को कर दीजिए. pH 9 के ऊपर जाहिर सी बात है वीक बेस है तो किसी एक एसिड को डीप्रोटोनेट करेगा. स्ट्रॉन्ग एल्कली है तो दोनों को डीप्रोटोनेट कर देगा. दैट इज द होल सिनेरियो. ओके, that's the end of this paper, guys.